Yeah, hello everyone. This is the continuation video on solid state. This is the solid state part 3. And in this video, we are going to discuss crystal lattices and unit cells. And from here onwards, the total actual concept of solid state will begin. And from here onwards, the total concept will depend completely on the visualization of the student. So, but as I told you before, we'll be discussing totally with the help of three-dimensional diagrams. And without making any delay, let us first understand what is the exact meaning of crystal lattice, or it is also known as a space lattice, and unit cell, different types of unit cells. That is our discussion. But in the first video, already we discussed what are crystalline solids, what are the characteristics of crystalline solids. For example, if you take this is an example of crystalline solid, you can see all the particles, all the constant particles are arranged systematically. And this systematic arrangement is repeated in the entire solid, right? Now, what we are doing is we are trying to understand the meaning of crystal lattice, which is also known as a space lattice. See what exactly we are doing. There are repeating particles or constant particles we have, and this constant particle may be atom or ion or molecule, whatever it may be, anything it can be. So if the particle is replaced with a point, if the particle, it may be atom, ion, molecule, whatever it may be, metal kernel, whatever, if it is replaced with a point, then whatever the thing you are getting, that is called crystal lattice, or it is also known as a space lattice. So space lattice means this is a systematic arrangement, three-dimensional arrangement of various points, and each point is said to be a lattice point, and each point indicates one constant particle. Each point is indicating constant particle. The constant particle may be atom or molecule or ion, whatever it may be. We have to use only one point there. It may be atom, or it may be molecule, or it may be ion. So whatever it may be, so while writing the space lattice, while writing the crystal lattice, so we use some points. So students always get a doubt if it is ice, that is a H2O molecule. In that constant particle, three atoms are present. Whatever it may be, that is represented by point. If for example, if you assume this one as ice and this constant particle, it is indicating a water molecule. It indicates a water molecule. If you assume this one as diamond, then the constant particle will indicate what? A carbon. If you assume what do we call, this is an ionic solid like NaCl, the constant particle represents ion. So while writing the space lattice or crystal lattice, what exactly we are doing? Simply the constant particles are represented by using some points, and these points are joined by straight lines. You can see these points are joined by straight lines, and when you do these things, whatever the thing you are getting, that is called a space lattice or crystal lattice, and these points are called lattice points. These are called lattice points, and this is solid. This is the representation, and here this whole structure is called a crystal lattice or space lattice. It is made up of lattice points, and here the small repeating unit. Here this is made up of many repeating units, and the repeating unit is called a unit cell. But we'll talk about unit cell. But here, what we discussed so far, a regular three-dimensional arrangement of points in space is called crystal lattice. Every point is important. There are 14 possible 3D lattices. 14 possible 3D lattices we'll discuss. These are called Bravais lattices, and how 14 lattices are developed, we have to discuss. and each point in a lattice is called a lattice point. Already told you, or lattice site. Each point in a crystal lattice represents one constant particle, which may be an atom, molecule, or ion. That constant particle may be atom or molecule or ion, irrespective of its nature. Always, while writing space lattice, the constant particle is represented by a point, right? Lattice points are joined by straight lines to bring out the geometry of the lattice. If all the lattice points are joined by some straight lines, you'll be getting the space lattice. So this is about the crystal lattice. Now let us talk about the unit cell. What is the exact meaning of unit cell? What are the different types of parameters we have for unit cells? See, this is just now we discussed the space lattice, right? This is a space lattice. In this space lattice, you have as the smallest repeating unit. The smallest repeating unit of space lattice is called unit cell. So when these unit cells are arranged like this in all three directions, you will get what we call a space lattice. When unit cells are arranged systematically in three-dimensional manner, you will be getting what we call a space lattice or crystal lattice. So the smallest repeating unit of space lattice is called a unit cell. That is the exact definition of a unit cell. It is the smallest portion of the crystal lattice which generates the entire lattice, when repeated in different directions. So you have to repeat unit cells along x-axis, y-axis, and also z-axis. Then you will be getting what we call a space lattice. And there are 6 parameters to define unit cell. There are 6 parameters. Based on these 6 parameters, unit cells are classified into different categories. From here, I told you already, you should be very careful, because if these basics are not clear, the remaining part of solid state, 100% it is impossible. Crystal clear clarity you should have, then only the rest of the topics can be understood easily, right? So what are the 6 parameters? There are 3 lengths, they are axial lengths, and there are 3 angles, they are called axial angles. See, for example, in this diagram, you can see this is edge actually, this is edge length along x-axis, this is edge along y-axis, this is edge along z-axis. Of course, like this we have, here we have 4 such edges along x-axis, 4 such edges along y-axis, and 4 edges along z-axis, whatever, right? And here, what is the length of this edge? That can be represented by small letters A, B, and C. A, B, and C. They are called axial lengths. And the next one, angle of separation between these 2 edges, alpha. Angle of separation between these 2 edges, beta. Angle of separation between these 2 edges, gamma. So there are 3 angles we have, 3 lengths we have, altogether 6 parameters. By taking these 6 parameters, we can develop a basic crystal systems. So we have what do we call a parameters. Unit cell is characterized by 6 parameters. So here dimensions along 3 edges, and the 3 edges may or may not be mutually perpendicular. Edges may or may not be mutually perpendicular, and angles between the edges. And these are the 6 parameters. Now, first let us take the classification of unit cells. Then we can go for Bravais lattices, basic crystal systems, and Bravais lattices. So now you got the clarity of a unit cell. So whenever the given solid is represented with the help of points, irrespective of type of solid, that is called space lattice. All points we are writing, the points are joined by straight lines. And this entire structure is called what do we call a space lattice. And these red color things are called lattice points. The smallest repeating unit is called a unit cell. Unit cell is characterized by 6 parameters. But before going to basic crystal systems, it is necessary to understand the different types of unit cells. So all unit cells are mainly classified, broadly classified into two types. They are primitive unit cells and centered unit cells. Primitive unit cells, basic unit cells, simple unit cells, all are one and same. Primitive or basic or simple. Another one is centered unit cells, right? And these centered unit cells are further classified into three types: body centered unit cells, face centered unit cells, end centered unit cells. Now we have to understand what is the meaning of this primitive unit cell. So with the help of diagrams, we are going to discuss. Wherever you are getting it out, what do we call, repeat the video, and just to see the video repeatedly, get the clarity, because rest of the solid state totally depends on these basics. So be careful. So primitive or simple or basic unit cells. What is the meaning of this? So if the particles are present only at the corners, that's it. No other place. Whatever the constant particle you are taking, it may be atom, molecule, ion, metal kernel, whatever it may be. If particles are present only at the corners, then it is called which unit cell? Simple unit cell. That unit cell is called a simple unit cell. Other name, primitive. One more name, basic. In this, you can see the remaining portions. This is edge center. This is face center. They are not occupied. They are vacant. If unit cell is produced in this fashion, then the unit cell is called primitive or simple or basic, right? Let us move on to centered unit cells. Centered unit cells, body centered, face centered, and what do we call another one, that is end centered. Students always confuse. It's not edge centered, end centered unit cell. End centered unit cells, right? And here, body centered unit cells. If anybody says body centered unit cell, what does it mean? It means the particles are present at all corners. You can see corner particles. These are corner particles. Along with these corners, the particle is also present at the center of the body. It is also present at the center of the body. All such unit cells are called which unit cells? Body centered unit cells. Body, here only it is giving name. Corners are however occupied, no doubt about it. It may be centered unit cell or primitive unit cells. Corners are occupied for sure. Here the name only giving, it's not a memory based. Body centered unit cells. Along with the corners, body center is occupied. Next, face centered unit cells. Face centered unit cells. See, to explain the diagram, I have chosen this diagram. To explain face centered unit cells, I have chosen this diagram. So along with the corners, particles are also present at the center of the face. Now, if you carefully observe, please observe this carefully. So in the continuation videos also, I will be seeing front face, back face, left face, right face, top face, bottom face, right? So in my opinion, this is right face. This is left face. This is top face, and here, this is once again. So this is a top face. This is bottom face. And you see carefully, this is a front face. And this is back face. Let me repeat fastly. Right face, left face, top face, bottom face, front face, and a back face. It's a cube actually. You know, cube has 6 faces. And according to the name, face-centered unit cells, the particles are present at the face centers. You can see center of the face. Here, right face center, front face center, left face center, top face center, back face center, bottom face center. And also all corners. If unit cell is produced like this, then it is called which unit cell? Face-centered unit cell. One more, I told you, I always, so here, generally the students are getting confused, like body center, face center, and they may be thinking like end centered, but it's not end centered. Sorry, it's not edge centered, it is end centered. It's end centered, not edge centered unit cell. See, end centered unit cells means no doubt the particles are present at the corners. So what is the point? And all four types of unit cells, 100% corners are occupied for sure. If only corners are occupied, primitive. Along with the corners, body center is occupied, body centered unit cell. Along with the corners, if face centers are occupied, face centered. Then what is end centered? End centered unit cells means alternate face centers or opposite face centers, not all face centers. See this top face here at top face center, there is a particle opposite bottom face. And here there is no particle. You can see right face, no particle. Left face, no particle. Back face, no particle. Front face, no particle. Alternate face centers. So here for this top face and this bottom face is alternate or opposite. That means two face centers are occupied in this diagram according to the definition. So here, this is about introduction to what we call types of introduction to space lattice and unit cells. So here, what is the exact meaning of space lattice or crystal lattice? And what are the points you have to know while converting given solid into what do we call space lattice? And the next one, repeating portion is called unit cell. And what are the 6 parameters of unit cells? And here the next one, what are the 4 types of unit cells? And in the next video, we'll be, with this knowledge, we'll be developing Previce lattices. And this will be continued in the next video. Thank you. Thank you very much.